My name is Michael Long. I work for NTT America in the Network Development Engineering Group. I'm not a huge fan of public speaking, so bear with me. About a year ago, I think it's been about a year, I gave a talk to TIP when they first started about NTT, what our current DWDM installations look like and what we're hoping for future deployments. We were just going through a product refresh and talking to a bunch of multiple vendors. And one of the things that we had, we really stressed, oh, sorry, is there a, yeah, hang on. I closed everything down. One of the things we really stressed to vendors, geez. I know, I don't know where that counter is coming from. Is this idea of disaggregation, which and to their credit, they actually did get it. So they disaggregated, but they didn't disaggregate enough. So the typical installations that we had is this amp, demux, ROADM, and then transponder all in one kind of chassis. And what we were really looking for was to disaggregate that and take the transponders out of the MUX, demux line system. We typically see about 10 years on a line system, and we found that we're constantly turning over the transponders much faster. So the next generation line systems that we were targeting was 100 gig coherent, and we weren't going to put any 10 gigs on this stuff. So we really wanted to get rid of the old, put in new transponders, and make it all 100 gig coherent. So that's kind of what we were going after. What we really would like to do is put a lot of this stuff in routers and switches in layer 2, layer 3 devices and manage them at the router level. They're not quite there yet, but it's something that's still on our roadmap. When I gave the talk for TIP, I was contacted by Waturo and Hideki Nishizawa. And they were really interested in what we were proposing. I think everyone's familiar with the Facebook Voyager application. It was a 100 gig box as well. I think ADVA sells it these days. It was a fixed module, and NTT really was looking for, we were really looking forward pluggable modules so that we could swap out CFP2 ACOs today, CFP2 DCOs, 400 gig ZR optics when they become available. We were looking for something that was much more modular. And so this is what NTT Labs came back to us with. A little bit about the optical transponder here. It has an ONL Linux-based platform. To program the Ethernet ASIC, it uses Microsoft Sonic. And then to program the transponders, there's a transport layer abstraction interface that we can use to configure the hardware at the hardware level. And then we requested configuration support like Juniper Commit or netconf yang. All of our devices at NTT are configured offline, and then a config is pushed to the router. So this type of automation programmatically was very, very important for us, and it's actually something we look for in all vendors. So that's what we came up with, and yeah, I mean, really, I can't stress enough about the software support for these things. Being able to do a full commit, a rollback in case we screw something up, as well as the netconf yang models was one of the most important things. And actually, everything on there the Cassini has supported for. Let me give a quick demo. So this was done in NTT Labs. The demo was over 1,000 kilometers. And they're just doing a couple of videos. You can see one video on the left is a direct connected, and then the other video is over a 10,000 or a 1,000 kilometer spool. I won't show the whole video. So you can see the Cassini box at the bottom. And then you can see how it goes through the preamp, inline amplifier, and booster, and out the other side. And that's just the line system. Oop, darn it. Let's end that. So let's talk a little bit about the software architecture on the Cassini box. Really, it's Arturo here who wrote the software stack on this thing. We use Kubernetes for the container system, for easy maintenance, upgrade, logging, that kind of thing. And there's actually 4 containers. There's the transport daemons. There's the sonic daemons to control the Tomahawk. The Redis DB, which is part of Sonic. And that's where the configuration file lives. And then there's a system CLI. So that we can upgrade. It's kind of nice when you upgrade the CLI, you don't touch any of the 4 daemons, you don't touch any of the 4 containers, that kind of thing. As I said, everything's on top of the orchestration Kubernetes, and then you have ONL, and then obviously the Cassini hardware at the bottom. So for the transport, it is based on how Sonic configures Ethernet ASIC inside the Sonic. Obviously, I don't know how many people are familiar with the Sonic stuff. There's a daemon called syncd, which interacts with the ASIC via SAI. And all the configuration stats are stored in the DB, in the Redis DB stuff. And so we took that same approach for the transsyncd configuration, the optical components, along with the transport abstraction interface. So what that gives us is the same code base for different hardware we could just plug in based on for transponders, which transponder we're using. As long as the vendor provides the SDK or some sort of library that we can talk to, it's just plugging in different applications. And actually, we've tested this. Originally, it was built with NEL transponders, CFP2 ACOs, and we just happened to have a couple of transponders from a third-party vendor called Champion One, and we just tossed them in there to see if they worked, and sure enough, they did without any software modification for us. So really, you can put in any kind of third-party optic for the DSP, and everything should work just fine. So this is an ongoing discussion with the TIP working group on if this transport abstraction interface is something worthwhile for them to pursue. For the system configuration side of things, like I said, it's the Sonic architecture, and we use we update their database. It is very Juniper-ish, so if anyone, I come from a layer 3 routing background. If anyone is familiar with routers and Juniper configurations or Cisco XR configurations, they support this thing called load replace or load override and commit, so that you can edit your configuration and then load a configuration all at the same time. It's not you load a line, hit return, and then that line takes effect. So you can actually programmatically push out configs to these routers, and if a configuration fails, it automatically rolls back. So you're not having to try to figure out, okay, where did it fail, and then do I have to roll back my configuration to get to a clean state again? It does it automatically. The configuration is stored in a Git repo on the Cassini box itself. And then there's also it's a JSON file with a netconf yang implementation on it. So I think. So the conclusion, we actually have this. It was running in NTT Labs. It's running in NTT America's labs in Dallas. We've put it over multiple transponder systems, or we put it under multiple line systems from different vendors. And it does work as an alien wave system, so we can just put it on top of our existing platforms when this thing becomes available. There is some software work that needs to be done on it. I mean, it's a little bit raw, but there's a lot of potential here because of the pluggability of it, as well as not having to bookend some of these devices, and you can use one on one side and a router on the other side, and that kind of thing. We're hoping to see some Voyager support in the future. It's something that we probably want. We're hoping that the OCP group and the open lines, or the TIP group, can work together and do some real work on this. We think it is a good solution for another vendor solution out there if you don't want to go with some of the other vendors. I think that is about it. So that was a real short demonstration. Any questions?
So we need about,
yeah.
Good. I am told they are recording these, or yes, so if you could pass this back. Thanks.
Hans-Jürgen Schmidtke, Facebook, so thank you. Awesome job. I really love this collaboration also that you enable, right, between OCP and TIP. What do you need exactly from the TIP working groups, right? So what I noticed is that that there's in TIP and the OOPT, right, there are already 200 companies, and by being very prescriptive what needs to happen, you can actually really steer those groups. So I would like to understand what you need from the different groups, OLS or tie extensions, or is there anything you can call out that we can work on immediately?
I mean, immediately, it's unfortunately, because of my work, I haven't had a whole lot of time to join a lot of the TIP discussions, and I missed them at OFC last week, even though I was there. I had some other issues pop up. What we're looking for, at the hardware level, everything is table stakes, right? It's the software that really sets products apart. So great software is what's going to win the day for us. And automated software, something that we could programmatically configure these devices with, so that we don't have a person going in and configuring devices. Consistent netconf yang models, so really working with the IETF on the netconf yang stuff that they've been doing. IETF was this week, and so we split our time here and IETF in London. But when we talk about these type of systems, it's really netconf yang, programmability, that kind of thing. What I'd really like to see from a TIP, I don't know if this is something that TIP would be willing to work on. It's something, every vendor has every vendor has a way to tell you from point A to point B what kind of hardware they're going to have and what kind of loss they're going to have, and what kind of OSNR you should see on those lines. And I'd like to see something that's vendor agnostic in that space. And I know that they're working on something like that.
Exactly. Yeah. So that I'm not sure exactly what you mean, but maybe the physical layer, the physical simulation environment that they're building, engine, they actually instead of making everything equal from a spec perspective, they actually take those specification of every vendor and you can plug it into a tool that is common. And then you get automatically the OSNR, the nonlinearities, etc. And they work on a GNPy, Gaussian noise Python library, so that you can actually immediately plan it as an operator. Yeah. So instead of standardizing analog hardware, you actually take essentially their response function, transfer functions, and then put it in a common tool that everybody's using. So it's kind of like another way of approaching analog technologies.
Right.
We can talk about that.
Yeah, I'd love to talk. Yeah, I'd love to talk about it.
Okay, I'm curious about TAI. I haven't, probably should have, but I haven't heard of it before. Can you tell me more?
Transport abstraction interface layer. So basically, it is just if you know how the sonic stuff works, it's the exact same way. So it's a middleware that I think probably Wataru could explain a little bit better than I could.
Yeah, it is a transport version of. Oh, sorry. Thank you.
It's on.
Okay. It is transport version of SAI, switch abstraction interface.
What does it do?
So actually, it is just C header files, just a collection of C header files, and each component vendors need to implement the libTAI to export the TAI header files. Yeah, it is same as
That makes
SAI.
sense. Upward. What does it do?
Yeah. So for our implementation, it is just poking I2 to bus using a generic Linux driver. And on top of it, we are using NEL's, because we are now using NEL's DSP, we are using NEL's SDK and implement libTAI and expose the API to the upper layer.
Okay, so is there a place I can get a spec for it?
What you mean by this? What spec?
As an optical vendor,
Mm-hmm.
how do I write the library?
Yeah, I think we need to talk with NEL because so Broadcom don't export the all specification to the users, right? Without any NDA. So I think it is same for NEL. So it is not the open specification about the DSP. So yeah, I think we need NDA to proceed at all. Yeah, I'm not sure.
So this is part of the process in TIP, that we actually come up with a TAI that we, with the support of all the member companies, can actually publish. So we are not there yet, but this is the current answer, but we will publish it. The intention is to publish it.
But there should be an API that everyone's looking at.
Yes.
I don't know how they implement it. I need to know the APIs.
Yes, it's part of the process. No, but I just need to advertise a little bit for this group, right? It just was established 12 months ago. We took a couple of things down, but that's part of the process, and I hope that we get there probably this year. And NTT has done an awesome job here to spearhead that abstraction interfaces and gains a lot of experience, and we hope to funnel that back and make it public and drive a little bit more. Not standardization, but more commonalities among the vendors.
Good, thanks. Other questions? I got 10 minutes before I'm supposed to start talking. Anybody?
Hey, hi. This is Liz from Facebook. So you talked about the ITF Yang models. So I was wondering if we could get your thoughts on like OpenConfig versus OpenROADM versus ITF Yang models, and how do you think that's going to play out?
I mean, my honest opinion is that it's going to the NetConf Yang stuff is going to start looking like SNMP version 2, where we're going to have a lot of and I hate to say that because everyone's doing a lot of good work, but we're going to see a lot of vendor-specific Yang models, like we see a lot of vendor-specific MIBs. I don't know. I don't have a good fix, unfortunately. Yeah, that's my personal opinion. And
which one would you pick if you could choose one to be the one that gets like de facto?
I really couldn't comment on that right now. I mean, right now we're not. I mean, we're pushing NetConf Yang, but internally we're not even using it. We're pushing a raw configuration to all of our devices, and then doing a load commit, because there's no standard yet. It's still pretty raw. And a lot of the NetConf Yang, you can't configure everything in the device yet, so you're still having to push some configs. So even the NetConf Yang stuff's still not there. I mean, I'd like to see the IETF stuff works, just because that's where everything. I mean, looking at some of the 100 gig, 400 gig, and 40 gigs, in the talk yesterday about how the IEEE and all their different specs, and they had to come out with an MSA that was very, very vague, and there was a lot of interoperability issues at 100 gig early on. My fear is that you're going to see OpenROADM and some of those guys come out with very vague netconfig that's going to force vendors to go that route. Where IETF, they take a long time, but they generally kind of do it the right way the first time. It's just a long, hard process. That's my feeling, though.
Cool. Thank you.
Give an answer you like. Make your pitch.
No. Thank you. No.
Anybody else?